In October 2025, the silence of deep space trembled. A Chinese telescope, FAST, the world's largest ear to the cosmos, caught a pulse repeating every 1.7 seconds, echoing across the stars. It came from 3I Atlas, an interstellar object thought dead, drifting between Mars and Earth, but the signal wasn't random. It responded. Each time scientists looked, it looked back. Its orbit shifted, its light brightened as though something inside had awakened. Not a comet, not a rock, something alive or something built. That observation changed humanity's understanding of life itself. When the sky surveys of July 1, 2025, reported a dim object moving against the background of Capricornus, no one expected history to unfold. The Atlas telescope in Chile, built for early warning asteroid detection, registered a magnitude of plus 18.3, faint but distinct. Its motion was rapid, cutting across the frame faster than any main-belt comet should. Within 48 hours, Orbital Solutions confirmed what astronomers quietly hoped and feared. The newcomer's eccentricity exceeded 1.03, meaning it wasn't bound to the Sun at all. It came from elsewhere, our third interstellar visitor, designated 3I Atlas. The last two such wanderers, Propulsion 2017 and 2I Borisov 2019, had taught humanity humility. They were reminders that fragments of distant worlds occasionally cross our neighborhood. Yet even compared to them, 3I Atlas was odd. Its trajectory originated near the constellation Lyra, approaching at nearly 42 km/s, a pace that would carry it across the inner system in mere months, not years. More intriguing was its brightness. Rather than flaring as sunlight struck, it remained constant, as though reflecting light from within. By mid-July 2025, observatories from Hawaii to the Canary Islands had locked on. Radar from Arecibo's successor network measured an object roughly 800 meters long, larger than Oumuamua, smaller than Borisov, with an unexpectedly smooth radar cross-section. Astronomers expected an inert comet nucleus. Instead, they saw consistency and reflection, lacking the chaotic tumble most bodies show. The rotation period appeared fixed around 9 hours, a neat rhythmic spin. Nature seldom chooses perfect integers. Within a week, its inbound path refined to graze within 2.1 astronomical units of Earth's orbit, passing between Mars and our planet. That proximity prompted urgent scheduling on the James Webb Space Telescope, JWST. When Webb's instruments turned toward those coordinates in August 2025, they detected not a fading relic, but something brightening. Though a comet should flare as it nears the Sun, but 3I Atlas was still far from sufficient heat. Something unseen was awakening it early. By the time it reached the orbital plane of Mars, telescopes noticed an impossible curve in its path. It wasn't escaping into the black, it was looping back, drawing nearer. What seemed like a coincidence of celestial mechanics became the first whisper of control. Instruments across continents began capturing emissions that pulsed like breath. The object's motion was no longer purely ballistic. It was behaving as if it had intentions, and from that moment, the story shifted from astronomy to anomaly. On August 18, 2025, JWST recorded a deviation of 0.002 degrees in 3I Atlas's trajectory. Small on paper, monumental in implication. Gravitational models could not explain the inward bend. Over the next 72 hours, the offset doubled. At 2.3 astronomical units, the object released faint jets of vapor visible in ultraviolet. Yet there was no solar impetus strong enough to justify them. Each burst lasted roughly 17 minutes, followed by silence of exactly 9 hours and 6 minutes, the same as its rotation. The cycle repeated 4 times in a single observation window. Comets vent gas as they heat. That's basic physics, but their releases are irregular, chaotic, and dependent on sunlight angles. 3I Atlas defied that rule. Its emissions came from symmetrical points, 2 near the equator, 2 toward the poles, creating paired plumes that seemed to adjust its spin rate. Analysts compared the thrust pattern to a micro-propulsion sequence, producing accelerations of 0.07 ms2. Tiny, yet deliberate. Over a week, those nudges shifted its perihelion distance by 0.04 astronomical units, a controlled change no random comet could maintain. Ground stations in Mount A Observatory, Japan, and Paranal Observatory, Chile, corroborated the data independently. Infrared readings revealed localized temperature spikes, heat rising from within, not from the sun. One hotspot measured 218 Kelvin, another 211 Kelvin, both far above the background of 50 Kelvin, typical for an interstellar ice body. Then, inexplicably, each spike migrated eastward across the surface, synchronized with rotation, as though a pulse of energy was circulating beneath a crust. That rhythm matched the venting cycle, turning the comet's own body into a dynamic thermal machine. By early September 2025, theorists suggested possibilities: trapped radioactive isotopes, chemical reactions between permafrost and organics, even piezoelectric heating, but none explained the timing precision. Each pulse was within plus or minus 5 seconds across multiple rotations. Natural randomness vanishes at that level of stability. In confidential circles, the phrase controlled propulsion began circulating. For the first time, astronomers faced a celestial object that behaved like a probe, self-correcting, alive to motion. When Djibouti spectrometers opened their eyes to the comet's coma in early September, the data that returned challenged every known category. Molecules appeared that shouldn't survive interstellar cold, and heat emerged where no star could warm it. Atlas was no longer a visitor. It was a system, a laboratory of alien physics, perhaps even biology. Spectral analysis from JWST's NIR spec on September 4, 2025, produced results that shook calibration teams. The coma of 3I Atlas was dominated by carbon dioxide, making up roughly 80% of volatile emissions, compared to just 10% water vapor, an inversion of every known comet ratio. Embedded within were faint traces of formaldehyde, ammonia, and complex organics, resembling polycyclic aromatic hydrocarbons. These compounds were organized in repeating intervals across the wavelength spectrum, not scattered as random noise. Some analysts whispered the unscientific word pattern. Radar echoes from Greenbank and FAST in Guizhou, China, revealed an even greater surprise. The interior wasn't uniformly solid. Density fluctuations appeared in evenly spaced bands, voids or channels recurring every 47 meters. Nature loves chaos. This was geometry. Combined with venting symmetry, it hinted at a structure, perhaps porous layers guiding fluid or gas like veins in an organism or conduits in a machine. The discovery forced mission scientists to reconsider what they were looking at. Was this a comet, a relic, or something built? Over 2 weeks, Webb's mid-infrared imagery showed color changes in the coma from gray to green-blue, correlating with hydroxyl emissions, the breakdown product of water. But the timing of those emissions matched not sunlight intensity, but telescope observation windows. Each time instruments pointed toward it, the hydroxyl spike rose by 12%, then faded when attention ceased. A comet that reacts to being watched. The implications spiraled far beyond chemistry into philosophy. Perhaps 3I Atlas was metabolizing light, or attention itself. Regular pulses of heat and rhythmic venting could hint at a metabolism, not life as we know it, but life nonetheless. As researchers examined those repeating molecular chains and thermal harmonics, a question emerged that science wasn't ready to ask aloud. If something can self-regulate, process energy and respond to stimulus, is it still a rock or a being? The first undeniable hint came from Mount Io Observatory on September 11, 2025. Using a high-speed photometric array, observers detected rhythmic brightening in 3I Atlas's light curve, pulses repeating every 9 hours with uncanny precision. Each burst lasted 43 minutes, followed by near-total stillness. When overlaid on JWST's heat data, the pulses matched the movement of thermal hotspots recorded earlier. The symmetry wasn't coincidence, it was synchronization. The object was exhaling energy in intervals like respiration across. Vacuum. Spectral decomposition of the venting material revealed narrow emission bands from hydroxyl radicals, the same fragments that appear when sunlight splits water molecules. Yet the flux of these radicals didn't align with solar angles. Instead, it rose and fell in tandem with rotational phase, independent of distance from the sun. By September 15th, models ruled out sunlight as the driver. The pattern was internal. Something beneath the crust of 3I Atlas was converting stored compounds into vapor on a predictable cycle. Chemical metabolism, in its simplest definition.